Okay, so this is 6.8, ready, set, go, number 8. So it says, given this information, find the rest of it. So first, draw the triangle. That's what we talked about earlier. So I'm going to draw a triangle like this. And I'm going to label this one A and this one B. And then this one C. And then, so you draw the triangle and then you label your triangle. So how do I label this triangle? 1 is the opposite and 2 is the hypotenuse for B. Okay, so square root of 2 is the hypotenuse. Very good, because they're remembering that this is the opposite and this is the hypotenuse from B. So the opposite guy is this guy. So he's 1. How many people got just that part right there? Are you guys okay with that part? Okay, so if you're okay with drawing the triangle and labeling your triangle, the rest of it is just like you remembering your definitions of so, ka, toa. So tangent, interesting, we don't have the other side. So we're going to have to find this other side. How do I find this third side of a right triangle? How do I find the third side of a right triangle? How do I find the third side of a right triangle? Yes, the Pythagorean theorem. Very good. So, Miss Johnson, I don't want to do the Pythagorean theorem because there's a square root here. Actually, it's not that bad when you square a square root. Watch. So we go 1 squared plus, I'm going to call this b. B squared equals the square root of 2 squared. What happens when you square root? I mean, you square a square root. What? Yes. They undo each other. So this is equal to 2. This is 1 plus b squared, right? Exactly. So b squared equals to 1. So therefore b is equal to plus or minus 1. But again, we take out the -1 because it's a side of a triangle. So this is b equals to 1. Is everybody okay with that? Yeah, right? I know. You guys were like, oh, I don't like the square roots. But look, they got rid of them. Okay. So now what I'm going to do is I'm going to find the tangent of A. So can you find the tangent of A? Can you find the tangent of A? So go from A. What is tangent's definition again? Yeah, TOA. TOA, right? So therefore, can you find that? And what would it be? Very good. Opposite, which is 1 over over adjacent. Sorry, opposite over adjacent. Yeah, so it's just 1. Ms. Johnson, is it okay if I just write 1? Absolutely. But be comfortable with knowing that it's also equal to 1 over 1. So if I say that the tangent is 1 and you're like, Ms. Johnson, it's supposed to be opposite over adjacent. They didn't give me another number. Be comfortable in knowing that I can put an invisible over 1 under any whole number, right? Okay, then what's the tangent of B? The tangent of B. Very good. It's still TOA, so it's 1 over 1. I'm just going to do 1. Okay. All right. What's the sine of A? What's the sine of A? Yeah. 1 over square root of 2. Miss Johnson, it's the same as the sine of B. Oh, that's weird. I wonder if that's a coincidence. Or is that a fact? Right? What's the cosine of A? 1 over root 2. Very good. And the cosine of B? 1 over... Miss Johnson, all of them are 1 over root 2s. That's weird. I know, right? So interesting. Okay, so very good. Questions for me for this. What's the hardest part? Now that you've seen it a couple times, what's the most difficult part for this? Yeah, right? Someone said that was easy. And it was almost intimidating because of the square root of 2, right? What makes this triangle so memorable? Actually, this is a famous triangle. If you actually think about who he is, he's called a 45, 45, 90. Because this angle in here is a 45, this angle in here is a 45, and this is 90. And so there's two special right triangles that are famous in trig, and this is one of them. Yeah, so you can still write these as fractions. You can write it as 1/1. In fact, I'll be honest with you, I like writing them as fractions because then if I have to like separate them like opposite over hypotenuse, then I know who is who. And it's just because they simplify. Yes, finding that third angle. So the third angle, don't forget that you have another tool, and it's called your triangle sum theorem, which means all the angles add up to 180. Very good. Okay.